Now I'm going to explain hazard analysis using the simple methods. Initially, you have to have a DEM file, and you have to open the DEM input file in the QGIS. So, covering your project boundaries, you have to have only I have to have only two DEM file. Next, I have to merge both of the DEM file together, and this is the process I'm going to show you now. So you have to select the DEM. This DEM is required for merge, and then you have to select the folder where you would like to save the output file, and then and this is the output file. So you have to write the name as far as your preference. This is the name I wrote here. So this is how then click OK. So no alternative is required. Okay, and it will automatically convert it. Merge. You can see the merge file here, and then go to the raster calculator. So here you have to calculate raster calculator. You need a return. You need a raster file DEM. You have to manage the DEM. So you have to select the output folder as like previous. This is the output folder. You can This is the output folder file name, and then click OK. So it had changed a little bit. You can see in the description. And then you go to the layer properties. You have to change the color codes and color gradients and type of classifications. From the layer properties, you have the opportunity to change this kind of features. So one by one, you need to change all the filters and click OK. Now you can see the changes. The color have changed a lot in the merge game, and this color shows the inundation depth. More blue means more depth of water. So inundation depth shows more darker blue have a more depth of water. So this is the layer properties. You can change the inundation depth. Example. So based on the land use, land classification, based on the definition of the land classification, you have to put all the values. For example, 0.0 F1 F2 F3 land. So based on that, you have to change the color, and 0.3 need to be transparent because this depth is not important. So I'm making it transparent to see more visible. Click OK. And again, you have to go to the layer properties and see the DEM resolutions. This is because this DEM resolution is very important. So this is IDW interpretation, make better resolutions in make better resolution DEM. So to improving the DEM quality, I just like converted and modify the DEM here. From the IDW interpolations to the process, you can change the DEM resolutions. So this is you have to show the folder where you would like to save the output file. Now it's okay. It's converted. Um, then getting more resolution. So cancel and next raster calculator. You can see the dem quality, the finer dem we also have. This is the boundary shape file I showed in the dem. Then again you have to do the raster calculations. The raster from the raster calc we have to minus the dem minus the what are produce shapefile minus dem. Click OK and show the output folder where you'd like to save and click OK and then running for the final process. And from the layer properties, you can change the layer properties, copy and paste. You can see the dim resolution or size of the dim from the bar ruler. You can see the indentation depth area, zoom in, zoom out. And from layer properties, we need to change the color contrast. So from the layer properties, you can change the color to make it more visible and more understandable of the indentation area. Then click OK. One by one, you can change the color code based on your preference. There is no rules. I mean, like you can change by your own uh, thoughts or by your chosen color. You can see more darker blue means more depth of inundation. Then raster calculator again. Now I'm going to calculate the 20 years return period inundation depth. So for that, like you have to have return period flood water level probability data, uh, and yeah, and then please open the attribute tables and add the water level 20 years return period water level value. Then click OK. From the attribute table, the field calculator, you can calculate the 20 years return period value. Danger level plus 0.181 meter per meter sea level water level you need to add, then you get the 20 years return period danger level data. This is the procedure I'm going to show you. In case return period and listen, you have to change the parameters. And this is the formula you can see in the screen. This is how you have to calculate the test return period. Click again IDW interpolation for change the name resolutions. This is the complete process I'm going to show you that can help us to do the final analysis. So for the resolutions, 30 meter by 30 meter or 90 meter resolutions, you have to copy the value and paste it, and this is how you can change the resolution of the depth. So you have to find out the output folder and some other parameter you need to change to complete the process. And show the output folder where you would like to save your output folder files. And click OK and click OK. And it will take little few seconds to complete the process, and now the output is visible now. So, so again the raster calculator, 20 return period minus the dim, existing dim. So then you will get the 20s return period inundation depth, the modified one. And then save the folder in a specific file folder with the name. It will take few seconds to convert it, finalize the calculations. And the layer properties, you can change the layer properties, copy and paste, then it will automatically converted the properties, then the existing one to the new one. So you can see the inundation depth, more blue color means his depth of water. So darker blue means the depth of inundation is high, and less blue means the depth of water is low. So now the procedure is the converted DM file raster to vector. So the next procedure is you have to convert it the raster value in the vector file for completing the process. So this is the process I'm going to show you now. So raster to vector, and show the folder where you would like to save the output file, and then write the name of the file and save it and click OK. So the process is done now. So only one steps is remaining. So this is again the layer properties, and you have to change the coordinate system because this one is not well, coordinate system was not defined before, so that like we have to change the coordinate here. So now again the layer properties, from the layer properties you have to change the color. You have to make more understandable uh, for the audience, and this is nothing, just like you have to change the color gradient based on the land classifications, F0, F1, F2, 3, F3 land. Mm. So uh, so the process can be very easy, and there is no more analysis steps is required at this point. Only you need to change the color combinations to make it more visible, more understandable of the inundation depth in the local areas. So now I'm changing the value based on the land classification. F0 land is 0 to 0.3, and this is how we have to change all the numbers, F0, F2, F3, and if required F4. So based on that you have to change the color as well, and that's all. You can see the change. So the change is visible now. And the 0.3 need to be transparent because this one we are not going to consider. And also again you need to fix the coordinate system. So I have changed the coordinate. Layer properties, we have to change the color combination again, and this is the inundation color so that everybody can easily understand the color combination. Where darker blue means like more inundation, less white color means like no inundations in this specific area. So this is only I have to change only the color combinations here. No more details is required at this point. The hazard analysis is done so far. This is only the modification and beautification work is going on. So I'm just like changing the color combinations as per my choice. There is no defined rules about the color codes. I mean, like you can change which color you require, but like for the inundation depth, we always prefer the blue color because the blue color can shows the water color, so that like the blue is the ideal color for the showing the inundation area. So it's better to use the blue combinations, then people can easily understand the depth of water. very easily. So this is the color I am going to choose. And, uh, and then the last one showing the darker blue. The purple. So this is the inundation area. You can see. So so that's all.